So welcome. Today we are going to look at the pentose phosphate pathway, also known as the hexose monophosphate shunt or the phosphogluconate pathway. So all those terms, the three terms refer to a common pathway. So I've said it is called pentose phosphate pathway, hexose monophosphate shunt, or the phosphogluconate pathway. So it has two phases. That is what you should know. An oxidative and a non-oxidative phase. Okay. So the oxidative phase is irreversible, but the non-oxidative phase is reversible. So oxidative phase is irreversible, but the non-oxidative phase is reversible. The oxidative, as you can see here, the oxidative phase or reactions, there are three reactions, and they usually convert in those three reactions. Glucose 6-phosphate will be converted to ribose 5-phosphate. Okay, so in the first reaction, note that in this reaction here, I've combined 1 and 2. So in the first reaction, let's talk about the first reaction specifically. In the first reaction, glucose 6-phosphate is converted to, let me write is converted to 6-phosphogluconate D lactone. Okay. So from glucose 6-phosphate to 6-phosphogluconolactone, the enzyme here is the glucose 6-phosphate dehydrogenase. Okay, and it is the one illustrated here where we put in an NADPH, NADP, and we dehydrogenate it. We dehydrogenate glucose 6-phosphate, and the NADP will undergo hydrogenation to form NADPH and a hydrogen ion. So in the second reaction, 6-phosphogluconolactone here is now the one which is converted to 6-phosphogluconate by the lactonase enzyme. Lactonase enzyme, we put in water. So here you will see some water coming in. Your H2O, you will see water. So here you will see water coming in. So here water will be, sorry for that. Sorry. So here you will see this water is the one which is used to hydrolyze. So it is added here. So the enzyme which catalyzes this reaction is lactonase. Also, you can call the other name of lactonase is 6-phosphogluconolactone hydrolylase, a hydrolylase. Okay. Then this was the first reaction here. Second, now the third here directly as they have written, from 6-phosphogluconate to ribose 5-phosphate, another NADP is undergoes hydrogenation, and also you can see here there is removal of one carbon in form of carbon 4 oxide. So in reaction number 3, we have two processes, dehydrogenation and decarboxylation. So this reaction is catalyzed by the 6-phosphogluconate dehydrogenase enzyme. So after removal of one carbon, this was a 6-carbon sugar, this is a 5-carbon. As you can see, 1, 2, 3, 4, 5. So ribose 5-phosphate, and it is a ketopentose. A ketopentose because you can see the oxygen there is attached to carbon number 2 instead of the terminal carbon. Okay, so ribose 5-phosphate. Then those 3 reactions are irreversible and they constitute the oxidative phase. Okay, then in the non-oxidative phase, first ribose 5-phosphate is converted to, and remember the non-oxidative reactions all are reversible. So it is converted to xylulose, this xylulose 5-phosphate by a 4-epimeris. 4-epimeris in what way? You can see here it's carbon number 1, 2, 3, 4. Okay, 4. So I want you to look. Sorry, it is not a 4-epimeris, a 3-epimeris. I'm confusing it with the epimeris in the Lilua pathway. I will also look at the Lilua pathway. So it is a 3-epimeris. So it changes the position of the hydroxy group. Here you can see the position of hydroxyl group here. It is at carbon number 3 on your right, but after the epimeris acts, it comes to your left. Okay, now this new compound is xylulose 5-phosphate, xylulose 5-phosphate. Then also ribose 5-phosphate can be converted to ribose 5-phosphate by the phosphopentose isomerase. So I want you to see the changes that it undergoes. First, it is converted from a ketopentose to an ardopentose. Okay, so you can see this is an ardo sugar, an ardopentose. This is a ketopentose. So I want you to see this oxygen here and this here. You see, that is the function of the isomerase does that. Ribose 5-phosphate is used in the nucleic acid biosynthesis. Then ribose 5-phosphate and xylulose 5-phosphate, they combine. Okay, they combine to form pseudoheptulose 7-phosphate and glyceraldehyde 3-phosphate. I want you to see something. These are 5 carbons here, and also these are 5 carbons here. So when they combine, they give you 10. So we must have a total of 10 carbons. So pseudoheptulose 7-phosphate has 7 carbons. So glyceraldehyde also has 3. The number of carbon atoms does not change. So I want you to see another very important reaction here. So there are 2 enzymes which are involved in the non-oxidative phase, a transketorius and a transaldolase. A transketorius transfers 2 carbon units, while a transaldolase transfers a 3 carbon units. Always remember this. They will transfer from a keto sugar to an aldo sugar, not the other way. Let me repeat. They will always transfer from a keto sugar to an aldo sugar. Okay, so like this is a keto sugar here. So these 2 carbons here, carbon 1 and 2, they are transferred. You can see this pathway here, they are transferred like this to there. So they came here at first to form this compound, which now has 5 plus 2, 7 carbons. The pseudoheptulose 7-phosphate. After the removal of 2 carbons, 5 minus 2, we remain with 3 to form glyceride 3-phosphate. Now, our glyceride 3-phosphate now has now become an aldose sugar, while our pseudo heptulose 7-phosphate has now become a keto sugar. A keto sugar. Remember, it is always from a keto sugar to an aldose sugar. So, in the second reaction, we will have a transaldose. It transfers 3 carbons. So, these 1, 2, 3 will be transferred to here, to the glyceride 3-phosphate. So 3 plus 3, 6. So we will have a 6 carbon compound known as fructose 6-phosphate. Can see this reaction. Then after the transfer of 3 carbons, 7 minus 3, we remain with a 4 carbon compound, the erythrose 4-phosphate. Okay. So the fructose 6-phosphate formed here goes to the glycolytic pathway. Remember, it will enter, then it will be converted to fructose 1,6-bisphosphate by phosphofructokinase 1. I will also look at that another time. Then the erythrose 4-phosphate, which has remained, is combined with, let me do that in a final color, with this erythrose 4-phosphate is combined with xylulose 5-phosphate. So let's look at this erythrose. So this is an, as you can see, is an aldose sugar here, aldose sugar, but this is a keto sugar. So 2 carbons will be transferred from the xylulose 5-phosphate to erythrose 5-phosphate. So 4 plus 2, 6. We will also form another 6 carbon compound, another fructose 6-phosphate. Then after removal of 2 carbon units from xylulose 5-phosphate, we remain with 5 minus 2, 3. A 3 carbon compound known as the glyceride 3-phosphate, which will also enter the glycolytic pathway. So remember, transaldose catalyzes transfer of 3 carbon units, transketorius transfer of 2 carbon units. With that, you have covered the pentose phosphate pathway, hexose monophosphate shunt, or the phosphogluconate pathway. Thank you, and subscribe for more biochemistry content.